Happy Friday to you all. Hope you're doing well. And hopefully you have been able to work through at least this first example, and you're watching the video here and seeing how everything has turned out. So number 14 is similar to one of the questions we did yesterday. It uses this key phrase right here, using integration. So that just tells us that one of the things we're going to need to do is integrate, find an antiderivative. So one of the ways, if I suppose maybe we could do this in a similar way to what we did yesterday. If I noticed that f prime of x is equal to 1 over 1 plus x squared, this might give us a little bit of a hint as to how we're going to use integration. The reason why this would be handy is because we would hope that we would look at this expression right here and realize that this is just a manipulation of the geometric series. So what I think I'll do is I'll take this and move it on down here just a little bit. And now that I've recognized that I'm working with some kind of a geometric series, I'm going to go ahead and write 1 over 1 minus x equals 1 plus x squared plus x cubed plus ... plus x to the n. And now I should be able to then take that and write a new power series for 1 over 1 plus x squared. And the way that I'm going to do this is substitution. So I could write something like this, that this is equal to 1 over 1 minus negative x squared. So all I have to do now is plug in a negative x squared and for all the x's that I have up above. So I'll do that. So it would be 1 plus negative x squared plus negative x squared squared plus negative x squared cubed plus ... plus negative x squared to the n. Okay, just do a little bit of simplifying here. You're going to find that simplifying is a really useful tool for us. So it'll be 1 minus x squared plus x to the 4th minus x to the 6th plus ... plus negative 1 to the n times x to the 2n. Okay, so let's remember that the first two words in the whole question said that we need to be thinking about using integration. I think this is where this is going to come into play. So what I'm going to do is find an antiderivative of both sides. So that'll be the integral of the left side and the integral of the right side, keeping that in balance. Okay, so over here I get f of x, and that of course is equal to arctangent of x, as noted up here. And this would equal, I just need to do the power rule several times. This will be x minus 1/3 x cubed plus 1/5 x to the 5th minus 1/7 x to the 7th. Plus ... plus it'll be negative 1 to the n. We still have that nice alternating pattern, but then I think it'll be x to the 2n plus 1 over 2n plus 1. And anytime you write an nth term, it's a good idea to look back on what you have and make sure that it fits the pattern. I think it looks like for me my n is going to start off at 0. That will give me a correct first term. And then if n is 1, that would be a negative, and it would be, of course, x cubed over 3, which does seem to fit here. And I think if we move on up to 2, 3, 4, whatever it is, I think we'll get the terms here that we're expecting. So once again, the directions here were to write a power series for arctan using integration, and so I would say that at this point, I've got it. So we could just write that as our answer and we're done. All right, number 15 reads, if f of x equals 1 plus x over 2 factorial plus x squared over 3 factorial, so on and so forth, It wants us now to give the Maclaurin series for g of x equals x times f of x. Now it looks like there's a little bit more that we need to do with this, but I'll start there. So I'm going to just try to tackle this right here. Okay, so we have this other function, g of x, that's equal to x times f of x. And let's remember that this symbol right here, this equal sign, is very powerful, and it's saying that f of x has the exact same value as that power series. So what I think I can do, if I'm going to write this Maclaurin series, I'll write g of x equals x times, and then in place of that f of x, I can just put this these first four terms that I'm given here for this particular power series. And I got the nth term here, like so. I can simplify this. In fact, I definitely want to, so I'll distribute that x throughout. So this will be x plus x squared over 2 factorial plus x cubed over 3 factorial. I'm hoping this is starting to look kind of familiar. Plus dot 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 plus x to the n plus 1 over n plus 1 quantity factorial. Okay, the reason I said I was hoping that it would feel familiar or look familiar is that the question then goes on to ask us to express g of x as a known function, like not just a series, but an actual function that we're supposed to know about. And so let's do a little investigating. This is kind of like two of the questions we did yesterday, where we start with a series and connect it to a function, instead of like some of the other things we've done where we start with a function and connect it to a series. So I need to try to connect this to some function. And if you remember from yesterday, I told you that the factorials are the best clue that you have about getting started. So we know we're supposed to know 4 unknown series, and we got to decide which one this looks like. Notice that the factorials go essentially 1 factorial, 2 factorial, 3 factorial, 4 factorial, and presumably 5, 6, 7, 8 dot 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 factorial. So of all the power series that we know, let's think this through. For sine, everything's odd. For cosine, everything's even. But for e to the x is the only one where the factorials go 1, 2, 3, 4. So I'm thinking that this is some version of g of x, or excuse me, of e to the x. So I'm going to write that down here. E to the x as a power series is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 plus x to the n over n factorial. Okay, so then if I try to compare what I see here with what I see here, I see that they're exactly the same, with just one exception. It's this 1 right here. For my g of x function, that 1 is not there. So all that really means then is that my g of x, and I'm going to write this over here to the right, this is equal to e to the x with the 1 taken off. So this would just be equal to e to the x minus 1. I could illustrate that similarly by, let's see here, by doing something like this. If I just subtracted 1 off this power series down here, so if I just did minus 1, that would give me what I want. But whatever I subtract from the right side, I've got to subtract from the left side as well. So once again, it's looking for, the question is looking for the function that generated this power series, and I would say that it's this e to the x minus 1 would give us the power series that we want. Of course, you could confirm this by taking e to the x minus 1 and using your Taylor construct to build it out term by term by term, and I think you would find that indeed it is what we are thinking here. Okay, I hope that worked well for you. A couple things you can do if you've still got some time. Number 1, if you are still not clear on having memorized the 4 power series, I suggest maybe getting with a partner, or maybe on your own, getting up on the board and having people let you know if you have it right or not. you should work on it, right? Because on Monday, if you don't know the 4 known series, it's going to spell trouble for you. So please do make sure that you have those 4 known series and their intervals of convergence and their nth terms absolutely rock solid. So you could be working on that. Also, you could be working on your extra practice, leading you towards your quiz on Monday. You could also be working on the homework, 9-9 to 9-10. Remember, that's paper homework, and you'll be turning those papers in on Monday before your quiz. You have a lot of options, none of which involve just sitting there. So I'd strongly encourage you to take the initiative and jump right in and get started on one of those items. If you have any questions or any issues, I'll check my email over the weekend. Let me know if you have something you want to talk about. And of course, that could apply to Monday as well. Just let me know. Keep me in the loop on what you need to do your best on Monday. So hope you have a good rest of your class and a good weekend. Look forward to seeing you next week on Monday.